Hi, this is Dr. Frederick, just talking about regression equations. What happens is that when you look at how two variables are related to each other, you might take a sample and look at some students that report that they study not at all, look at their average score on an exam. Or let's just say we had 11 students we were looking at here. This is what we found. One student says that she didn't study, another says he studied 1 hour, another says she studied 2 hours. And then we look at their scores. Well, we can plot them out. These blue squares represent the plots, and we see that it's not a perfectly straight line. There's some variability among there. Well, what we might want to do is we might want to be able to predict what your score is given how many hours you study. And so what we do is we find the line that we could draw through these points that is the most efficient line that reduces the error between that which is predicted and that which is observed. So the distance between the line and this square would be an error. Very tiny error here, some error, some error, some error, some error. This line, this particular line, is the one that reduces the overall squared error between the line and the points. And this is the formula for the line. And it says that the value of y, which is the score, the percent correct, is equal to this value, 6.12, times the number of hours, x, studied, and then add the number 46. And so we see here that when the number of hours studied is 0, the line predicts a score of 46. That's an error, but we'll take it. Here, when there's a score of 1, 1 hour studied, this is the predicted score. The line is the predicted score, the blue score is the actual score, so on and so forth. And we could just put a formula in here to predict what we would see given how many hours you studied. And if you look up here in the formula bar, you see it's just our regression equation. I just multiplied 6.1273 times the hours studied, and then I added 46 and did that all the way down here. So that's the usefulness of a regression equation. Very, very helpful and a very important part of statistics. Well, what we notice is that we're always going to have error, and in particular here we see that we have some impossible values that are predicted. The way that we get better and better at predicting is to take more and more observations and to reduce our error in prediction. What are the parts? The predicted value is y. The observed or the independent value, x, is what we use to predict y with. This is the multiplier or the slope of the regression line, and this value is called the y-intercept or the intercept value. So it says start at 46, which is where we did. That's the intercept, and then increase 6.1273 y's for every 1x, and that's the slope of the line. So as you say, okay, if you do nothing at all, you're going to get a 46 on your final exam. What will I get if I study 1 hour? Well, add 6.12 to 46, you get 52. Well, what if I study 4 hours? Well, 4 times 26 is 24, plus some change, you're going to be about 70 and a half. Well, I want to get a 90. How many hours should I study? Well, I should study at least 7 hours and upwards of 8 hours to get at least a 90. That would be a safe prediction. So the regression equation is our line of prediction. It predicts what y we will see given a certain x.